Hi, welcome to Ethereal Mechanics Behind the Scenes number 5. Here we're going to discuss recent developments in Ethereal Mechanics and the path forward. And recent developments, I got the fractal algorithm working in debug for circular cross-sectional wire structures. Then I applied that to the triple loop experiment data. I'm going to show the comparison of all the data sets for the triple loop experiment. But first, before I do that, let me give you a reminder where we left off with the Rhombus experiment, because that's related. At the end of the Rhombus experiment, we ran the new induction search tool, and that tool showed that there were two field geometries that fit all the experimental data to within the ability to accurately measure the data. That's geometry 5008 and geometry 5079. 5008 is a spherical field about an accelerating charge. That's what the double arrow means. Where 5079 is a longitudinal field. It's in line with the accelerating charge. Neither of these are the B model from classical theory, which would be a field model which is transverse to a charge. And the problem I ran into is in 20 years ago, I used mutual induction experiments where I thought that I was able to show that this was the sum of this plus the transverse field. That did not happen. Okay. Now the problem with the Rhombus experiment is, and the software, is that we're using wires that are filamentary thin. In other words, wires that have no cross section. It's just a filamentary thin wire, and that's what all the calculations are based on. But the new fractal software considers wires that have a real solid geometry. And I figured, well, this would make the difference, because if you put this guy into a solid wire, okay, the lobes forward and after are going to be in the wire, but the lobes that would be on the transverse field, some of those are going to be outside the wire. And therefore, you should get a different answer whether you use this or this in a solid wire. Where in a filamentary wire, it doesn't matter. Because in a filamentary wire, if you have the longitudinal field, you're going to get the same amplitude there that you're going to get with the spherical field. And so the part of the stuff that's outside of the filamentary wire doesn't matter. And that's why I assumed that when I applied these models using the fractal algorithms, which consider the whole volume of the wire, that I should get a different answer. Well, I did not. I got identical answers. Okay, let me explain what this is. This is the 22 gauge loop, the 26 gauge loop, and the 30 gauge loop. These are what we measured with two different measurement runs using the Agilent LCR meter. This is what Jackson computed. This is what Maxwell this is what we found by complete accident here, that if you take one loop and another loop, where the distance between these two loops is the radius of your solid wire, and you compute the mutual inductance from one to the other, this is the value you get, which is incredibly, remarkably accurate to a whole. It's incredible. It's just the most amazing thing that a simplification like that exists. This is the solid wire fractal algorithms using geometry 5008 and 5079, and you can see the answers are identical. And they match very quick, they correlate very well to experiment and this. And of course, the Jackson stuff is out to lunch, as we discussed earlier. And so now the problem is, now we have three different models that pretty much give identical answers to and match consistently with the experimental values. And this is based on the transverse field. This is the longitudinal field, and this is the spherical field. And let me put them in a diagram like this. Now, the only thing really different between the results is the spherical field only took 200 seconds to compute for each individual loop, where it took over 800 seconds using the same algorithm, except for the geometry is different, but using the same fractal algorithm to get a converge on an answer. I also did a modeling of this in a separate algorithm to compute the mutual inductance between the two loops, and this is a two-stage process. So going forward, I don't think this is the right answer. This is a two-stage process where these are direct processes. So I think we're going to kind of push that one off to the side right now because this takes the longest of the three to compute. And there's no need for all that unnecessary complexity in computing when you can get the same answer with these. The question is, if there is a transverse field which would look like this, and if you sum this with this, you do in fact get that. But the reason why this doesn't assert itself in a closed loop is because this is probably a conservative field. In other words, if I had an accelerating charge here, and I put a complete loop of wire, then the energy that's passing this point, which would give a negative impulse, would eventually hit the opposite side of the wire and give you the same amount of energy in the opposite direction. Oh, that would be this way. And they cancel. So the reason why, if there is a transverse field here, it's got to be conservative. That would be the only explanation why it doesn't show up in solid loop or even filamentary loop experiments. It's because it's conservative, meaning that if you take a closed loop in a conservative field, your answer is always going to be 0. Therefore, there's no contribution to a closed loop from the transverse component of this guy. That's why the longitudinal and the spherical give the same answer, is because the transverse is conservative. That's where I'm going to go with this. So the question is, does the transverse components of the spherical field really exist? And the reason why we have to resolve this, okay, because if you remember, when we go lower, remember we're going from electronics, which we can measure at the bench level, to pretonics, which is something in my laboratory we'll never have any equipment to even touch a preton, at least not until this gets accepted and people can spend a lot of money developing equipment to look down at that level if it's even feasibly true. So all of our observations have to be made at the electronic level. And we're using new electromagnetism, which I'm trying to make as the most complete, less ambiguous models of electromagnetic observations. That aligned with corrected vector algebra, which I'm calling Q algebra, and a new wave theory, which I haven't released yet. Somewhere, these models are going to overlap and give us a solution. And we may end up with another solution that's pretty good that we may have cause us to have to disambiguate between. And I've explained this before. In order to go from the electronic echelon to the pretonic echelon, to go down. Because we're not going to be able to see this. So everything that's here we have to infer from this level here. And that means having everything at this level as completely understood as we can possibly make it. So at this point, if we have a known ambiguity in electromagnetism, then the possibility that we're going to have multiple false positives at the lower level is a definite assurance. So it's in our behoval to resolve this error, this issue, this ambiguity before we go further. So the way to go forward is to open the loop. We need to make measurements that don't have a closed loop so that we can determine if, in fact, the transverse components of the spherical field really do exist. And we can't use mathematical analysis or computer models or all that stuff because those are completely out of the question because they're going to be based on the measurements we made of closed loops. And because of that, they're going to mimic the closed loop results. So we can't use anything we have now. So we have to devise an experiment to do this, to measure the transverse field, if in fact it does exist, without incurring the cancellation that we get with the closed loop. Now I thought of an initial experiment by getting these cute little Arduino 2.4 gigahertz transceivers and snipping off the little antennas they put on and make a nice 2.4 gigahertz dipole. And then make a dipole measurement experiment. And there's two bad things with that. Number one, you could probably go on AARL, and they've probably already done experiments similar in AARL's American Radio Relay League, where they do a lot of antenna stuff. But I don't know if I can trust what's published on other websites because I don't really know. Last time I looked, they didn't really specify exactly how they measured the fields. And also in other antennas that I've actually measured for other work, I've actually seen dipoles radiate spherically. Okay, but all of this is based on that we're going to be transmitting with waves. And that means we have to be sure of exactly what an electromagnetic wave propagating through space is. And so we don't really have any assurances of that even, because we're going to be doing the new wave theory to explore new wave theory. So it wouldn't be good for us to use something that's going to knowingly use an electromagnetic propagating wave when we haven't really looked into or explored wave theory yet. So this is the cart before the horse. So the path forward is going to be a high voltage experiment, which I plan to get into high voltage experiments for other things, but this is just another good reason that we should start getting into high voltage experiments. So the present idea, and I'm kind of wanting to something else right now, but is to basically get an acrylic wheel, like a plexiglass wheel, mill a hole and put a copper disc in it and close the disc off with epoxy, but put a little way to charge it, like a little feeler piece of copper, a whisker of copper sticking out so you can charge it. And then have a high voltage power supply that will allow us to charge that metal disc to a high voltage, and then be able to spin this disc and then use this motion of this single quote-unquote charge in motion, not a single electron in motion, a single charge in motion, and be able to measure based on its acceleration what does the field look like on its acceleration. Now I've been thinking about this more since I made this little plate here, and I've been thinking more of possibly making a little charge, hanging it, and then shooting it with a BB to make it accelerate away from a detector, to give a lot of acceleration, because this is only going to have the acceleration from the centripetal motion of and basically what I need to do is do the calculations to find out how much acceleration I need that I can possibly detect with the equipment that's available in my lab right now. So this experiment is going to take at least 3 months to develop, and I'll make video updates on where we are with this as we go. So don't be discouraged. This encounter is wonderful. Remember what Niels Bohr said, it's wonderful that we have met with a paradox. Now we have hope of making progress. And I remember many years past in ethereal mechanics where I was stuck for months, almost years at time, where nothing moved forward because I just wasn't thinking right. I didn't have my brain in the right way to understand the subtleties of what was wrong to be able to move forward. It's great. We have a lot of things in the works that need to be corrected. Q algebra is being corrected and updated. The resolution of this ambiguity is another thing to do. There's other ambiguities that are popping up, which are great, because it's showing us, all the flaws that we need to resolve to go further. And every flaw that we resolve makes our going further stronger and stronger. The only problem I have is I have a limited free time to devote to this. Because of the new ambiguity, it's going to require a lot of time to develop. There's not going to be many ethereal mechanics videos released until there's not going to be any, except for the Foundation Series stuff, until 2016. But in order to keep the interest of the site alive, the following videos will be produced this year. The new science series will begin with the Stinty's Gateway Feedback Theory of Science. It's highly improved, and it shows exactly the ambiguities we're seeing now are all part of the scientific process. And remember what I said in the earlier ethereal mechanics videos, that scientists every 20 years or so should get liquored up and then have a big convention and go back and review everything they've done to find, well, that's exactly what I did in the Foundation series, and that's why we found that I did make a mistake 20 years ago. I'm pretty sure the spherical field is the right model. Okay, and I'm pretty sure I chose wisely back then, even if I did make a mistake with how I resolved it. But that doesn't matter. We still have to do the work, cross our I's and dot our T's, or whatever the expression is. I'm going to do 3 more Distinti World videos, one about the two-party scam, Saving the Republic, and the Utopia fallacy. These are all, I'm trying to get these done for the next video release, get these out of the way. Rules of acquisition, all for the version 3 rules of acquisition are being released. We will have 6 through 15. There's some missing numbers here because the 7 and 8 are already revised for version 3 of the rules of acquisition. I'm not going to read these to you. You can read these on your own. And new series. I've got enough people that pretty much said they're interested in how to improve, use your mind. Well, new series is how to use your retarded monkey brain. How to make the best of the human brain is highly defective. I mean, it really is. I can show you examples of the stupid things humans do. War for one of them. And what blocks us from performing better. What evolutionary garbage clouds our thinking. Why we are so bad at decision making. I mean, consider that 50% of the marriages end in divorce. 9 out of 10 businesses don't make it to 10 years. Most of the airplane companies that sprang up in the 1920s, of all those millions of airplanes, like 3 or 4 left. Of all of the internet startup companies that started in the 90s, there's only a few real top ones left. A couple of smaller ones have evolved, but basically most businesses go out of business for a lot of stupid and interesting reasons. And I'm going to show you how that your future survival depends on making the most of your brain. Getting the most out of it. That your brain is going to be what you need for the future. Nothing else. And this series came from thinking about the rules of acquisition and how I have been blocked in the past and coming up with the rules of acquisition to offset the blocks that are in there. And like I described with the puzzle series of how easily it is to get your brain wrapped around the axle, how easy it is for our brains to get misdirected. So there's a lot of interesting stuff there. And I want to get this out of my brain because I've been thinking too much about it. And you guys understand that sometimes I got to get this stuff out of my brain, put it on a video, then it gets out of my brain, I can go on. So some of the stuff is not just to fill the video, it's just to get this crap out of my brain. And we have to start the New Wave Theory course. We need to start getting into this. It's going to be one of our 3 prongs to go down as we described at the beginning of this video. So we need to start developing this and developing the New Wave Theory stuff. So I hope to have the experiment where we disambiguate the field for induction completed, with videos of course, by December 15th. And I'll still be producing updates on this as we go. I won't leave you in the dark. You'll know where we are with this as we go along. So thank you very much.